Now we have to learn motional EMF. In that we have to consider two cases here. The case number one, when straight conductor is moved in uniform magnetic field. Now in this case, how much is the EMF induced in that conductor that we have to obtain? So when straight conductor is moved in uniform magnetic field, let I consider a straight conductor of length L is moved in uniform magnetic field with velocity v. So this is velocity of conductor and the field strength means magnetic field is B, magnetic induction. Let I consider dx is thickness of conductor. So what we consider here? We consider a straight conductor of length L is moved in uniform magnetic field of induction B with velocity v. Let dx is the thickness of the conductor. Now let I draw the diagram here. So here, so this is the magnetic field. So this is straight conductor. Thickness dx, length L, and it is moved with speed with velocity v. Let I show the magnetic field also by this type of signs. So direction of magnetic field is like this in a plane of paper. Okay. Now here we have a formula of EMF induced that we use. Hence, EMF induced is, by Faraday's law, EMF induced is E is equal to, I am considering the magnitude here, so d phi by dt. So this is the formula. Now here we can use this formula. So here d phi, this d phi we can write B into dA divided by dt. So we have a formula of flux phi is equal to, we know the formula of flux phi is equal to B bar dot A bar, or B into A basically. Now here B as it is, dA, this is the area. Now this area of the conductor is length multiplied by this thickness. So I can write L multiplied by thickness is dx divided by dt, or we can write BL dx by dt. So this is EMF induced, or I can write this is BL dx by dt, I can write velocity. So EMF induced in a straight conductor is BLV. So remember this formula very well for the problem point of view. Problem may be asked if straight conductor whose length is given is moved in uniform magnetic field of induction B, and then we have to find out the EMF induced, then we can use this formula. I hope you understood. Now the second case we have to discuss here. When straight conductor is rotated about one end, I can write it here, is rotated about one end in uniform magnetic field. So only the thing is here I have to write rotated about one end. When straight conductor is rotated about one end in uniform magnetic field, how much is EMF induced in the conductor, that we have to find out. So I consider conductor of length L is rotated with angular velocity omega. So I can consider here omega, angular velocity. in uniform magnetic field of induction B. Okay, that we consider. Now after that, we have to draw a diagram here. So let I draw a diagram. So this is straight conductor whose length is L and it is rotated about one end. So we get this type of motion. Now I consider, so here a part of this conductor, and that part I named it as a dx. Now the velocity of this part is v. You know that in circular motion velocity is tangential. So I consider this dx. Now first we consider EMF induced in this dx part, or I can write dr or dl. I write dl here. So this is a dl, is a small length element of this conductor. Then EMF induced. So I consider dl is small portion of conductor. Hence EMF induced in dl is. So I can write, you know, the EMF induced in a straight conductor is given by formula E is equal to, just we learn, BLV. This is a formula. So this formula we can use. Instead of E, I can use DE because it's a small part, DE. So B is a magnetic field, length of this part is DL and speed is V. So equation number 1 we get. So this is the EMF induced. Now after that, EMF induced, we have to find out the total EMF induced. So total EMF induced we get by integrating this. Hence, total EMF induced is, so E is equal to integration of this dE. So I can write it here, integration sign B dl V. So this V we can write R omega, but V is equal to R omega. So here R omega, the radius is L. So I can write V is equal to L omega. So you have a formula V is equal to R omega. By that we can write it. Hence E is equal to integration of B dl L omega. Now B is a constant, omega is constant. Take it out. Integration of L dl. So integration of L dl is L square by 2. So B omega L square by 2. So we get a formula 1 by 2 B omega L square, and this is EMF induced in this conductor which is rotated about one end in uniform magnetic field. I hope everyone understood this. Also the same formula we can write. Also you know that omega is, by this formula, V by L. So V by L. Hence you can write it here, E is equal to 1 by 2 B V by L into L square. This 1L and L get cancel. 1 by 2 B VL or BLV I can write. So you know that in straight conductor, when straight conductor is moved in uniform magnetic field, then EMF induced is BLV, E is equal to BLV. But when it is rotated about one end, then EMF induced is half BLV. So this is EMF induced. I hope everyone understood this article. When straight conductor is rotated about one end, then how much is EMF induced in that conductor. So you can see exercise, in exercise questions are asked based on this article.